I'm Casey Tran of MAAT Energy. Um, good. I'm trying to move the screen here, Adriana. Okay. Yeah, good morning, everyone. I'm speaking on behalf of MAAT Energy, and thanks for the opportunity to speak here at the MIT Demo Day. We are a team of MIT, of engineers from MIT and other universities and industries. And in general, we like to solve big energy problems. And we have been successful over several decades in designing reactor engines in the nuclear, automobile, power, and chemical industries. MAAT Energy is located in Harvard Square in Cambridge, and we have a French team in Lyon, France. And we are at the moment proving the use of microwave energy to convert methane to hydrogen or synthesis gas at full scale at a gas field with a gas partner. We are primarily funded by innovation grants from the US Department of Energy and the French agency BPI France. And we are incubated by Symbio, JV of Stellantis, Faurecia, and Michelin. A microwave can generate very high temperature heat in a specific way. We can convert methane into hydrogen and carbon solid, or we can reform CO2 into syngas at the right mixture to produce methanol or sustainable aviation fuel. We can also drive the synthesis reactions from methanol or ammonia. And these reactions are basic to decarbonization. It is easy and to install a unit. It takes more money to start a decarbonization project with energy modular systems. We like to do pool development and avoid not invented here syndromes. We are diligent in filing patent applications internationally and have secured a patent. Early in the research, we partner with MIT, UMass, Harvard, National Labs, and multinational companies. We are demonstrating in a gas treatment site to prove the economics of the technology and the path to grow by network effect. We are about to start up a full-scale demonstration here. I'm calling you from the field. The objectives are to stress test the systems and to validate the performance. We can only test at 50% of power because limitation at the lab, because we are in the middle of a residential area. The demonstration will provide validation of scale-up factors. We are looking for ideal customers who would be willing to have a soft startup in application in energy storage with available low-cost CO2, renewable power, or biogas of all sources. And we are also looking for partners who can help us through the network effects to deploy standard applications at multiple locations. And outside of the US, Canada, and EU, we are looking for partners to license the technology. Thank you, Adriana. We're ready for questions.
Thank you, Casey. Great presentation. So tell me a little more about how MAAT Energy is competitive or viable in the energy transition or hydrogen economy.
Yeah. So conventional technology for hydrogen production are primarily two methods. One is steam methane reforming, which is basically using natural gas or some other hydrocarbon sources to heat up and drive the reactions. And that process is efficient. It has been in the industry for half a century, but it is releasing high emission every kilogram of hydrogen you produce, you emit 10 kilograms of CO2. The other technique is using electrolysis, which is 5 to 6 times more energy intensive than the method we use. So it is clean, it is also proven, but it is energy intensive and is not economical. So hopefully we will be able to be efficient and clean at the same time.
Great. And this touches on another question from the audience. Can you talk a little more specifically about the price and the energy needed?
We're looking at 1 megawatt unit. So a megawatt system for us is we can produce 2 tons of hydrogen per day. So you can calculate that, depends on your assumption on energy cost, dollar or euro per kilowatt hours.